Okay, guys, so let's recap what we talked about in the previous video about the two-sum problem. And we mentioned that if you have an array, let's imagine A, B, C, D, E, and we're trying to find which two numbers will add up to some target T. And one solution, which is the brute force solution, as we discussed, is to try every possible pair, every possible unique pair. So in that case, for example, you'll try A plus B, A plus C, A plus D, A plus E. That will give you 4 different comparisons. And then you can try the same thing, B plus C, B plus D, B plus E. So that's 3 different comparisons. And then you could try C plus D, and then C plus E. That's 2 more comparisons. And then the last one, D plus E. That's 1 more comparison. Overall, that will give you 10 different comparisons. So 10 different computations for an array or a list of size 5. So notice that's a size equal 5 list. And that's a pretty inefficient. Brute force is always inefficient. Why is that? Like, what is runtime in that case? So I mentioned in the other video, one way to see the runtime using arithmetic sequence, arithmetic series, series, not sequence, because we're adding numbers here. Another way to visualize it is to draw it on a grid. So you can make a grid like this. And you can put the indices on each axis, okay? So you have index 0, index 1, 2, 3, 4, blah, 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 until the last index, whatever it is. In that case, if you have size n list, the last index will be n minus 1. Similarly, 0, 1, 2, 3, yada, 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 until n minus 1. Okay? So to try every possible pair, you're comparing index 0 with index 1, index 0 with index 2, index 0 with index 3, index 0 with index 4, and so on until index 0 with index n minus 1. And then you'll try index 1 with index 2, index 1 with index 3, index 1 is index 4, and so on. Index 2, you'll try it with index 3, and then with index 4, and so on. So if you notice, you are going to get a triangle after all. So you'll be getting something like this. Keeps going on. Okay? You'll have so many comparisons here. Each one of these dots represent one comparison, one computation. So let me move it a little bit. I feel like I'm getting a little messy. But yeah, I think that looks good here. Let me extend the axis. Change the color, get it back here. So you have ouch. Okay, and put the n minus 1 all the way here. That's the last index. And basically, you're getting all these dots. Each dot represents one computation. And when I say computation, I mean you're testing summation. You're adding 2 numbers, okay? I think that one is not supposed to be here. Now, when you check the runtime, I think one more maybe. Yeah, anyways, you get the point. So how many calculations, how many summations we're trying here? Well, it will be the number of dots in that triangle. The triangle keeps going, growing. And until you hit the n minus 1, you'll get some triangle like this. So the number of these dots is basically, if you want to get a sense of how many dots are there, how many calculations, it's you can think of it as the area of the triangle, okay? And how is that related to n minus 1? So if you look at that guy, how many calculations or how many dots here? Well, you do from n all the way to n minus 1. And how many dots here? Well, you have starting from 0 all the way to n minus 1. So, what is the area of a triangle? Do you guys remember? It's half the base times the height. Okay, well, I have from n minus 1, from 1 all the way to n minus 1. So that will give you n minus 1 dots. And then that's the base multiplied by the height of the triangle, which is n. And then you divide by 2. That will give you the area of the triangle. So this will be some function of n squared. You get n squared minus n divided by 2. And that gives you half n squared plus half n. Basically, that gives you something, a function of n squared, which is O of n squared. Why do we say O of n squared? Well, let me make it a little bit, it's too thick. Let's make it a little less thick. Why am I saying O of n squared? Because the highest exponent is n power 2. Power 2 or n power 2, that's the dominant term. You can think of it as when n is too large, like 1,000,000 or 1,000, this is the dominant term. So this is O of n squared. So that's why the brute force is not a good idea, okay? So that's a way to visualize the runtime, is how many dots are there. All right, okay, so what's the other way around it? The other way to solve this is, as we said last time, we are going to sort the array, okay? So again, if I have the array sorted already, this is just a recap. We discussed this last time, but this is a recap. If I have my array now sorted, so A, B, C, D, E, maybe F, okay? If this is sorted, basically what I'm saying is A less than or equal to B, less than or equal to C, less than or equal to D, less than or equal to E, less than or equal to F. Okay, so if it is sorted, what can I do with that piece of information? Sorted array. How does that help me get the right target? Find the target when I sum. How do I find the pair that when I sum I get the target T? And basically it's a simple test. We check the far left and the far right, okay? So this guy over here with that guy over here. The biggest and the smallest, okay? And we have two scenarios. If A plus F, let's do A plus F. There are 3 scenarios, sorry, not 2, 3. Larger than T, so let's put larger than T. T is the target number. Less than T, equal to T. There's no other way, okay? If the sum is larger than T, well, what does that mean? Well, if it's larger than T, that also means that B plus F is going to be larger than T. So B plus F will fall to the same bracket. C plus F also is going to be larger than T. Well, also D plus F is going to be larger than T. E plus F is going to be larger than T. So there is no point of doing these computations, because I already know from this inequality that if A plus F is bigger than T, then anything bigger than A, when I add it to F, will be bigger than T. Okay, so this is not needed. Okay. Okay, so now what if it's less than T, if A plus F less than T, well, that also means that A plus E is going to be less than t, a plus d less than t, a plus c less than t, a plus b also less than t. So these are also not necessary. I could avoid them completely. If a plus f equal to t, well, then I'm done. And that's about it. Okay, so one way to think about it is when I do a plus f, if it's bigger than t, what I'm basically doing, I am eliminating a completely from the array or from the list. You can think of it as you're starting the problem again with a whole different list. In that case, this list. If a plus f bigger than t, basically you're repeating the same problem, but with a new list where a does not exist in that list anymore. Okay? So basically you're repeating the same problem over and over. But you're doing it, but with b, starting from b. But let me go back. What if a plus f less than t? Basically, you're repeating the same problem as if f does not exist in the first place. So you're repeating the same problem with from a all the way to e. Okay? And you keep repeating the same problem over and over and over and over and over. So you either eliminate someone from the left or somebody from the right. Okay? And you keep trimming the list. You trim it, you trim it, you trim it. Either you lose somebody from the left, somebody from the right, and until you end up finding the right pair. Okay? The problem here says there is a unique solution, and there exists a solution, a unique solution, so we know that we're going to find the pair at some point. Okay, so what will be the runtime in that case? Well, let's see. It's not O of n squared, and that's for sure. Because we're not trying every pair. Because we did not try every pair. Why is that? Because we were pretty smart and we did the sorting first, and we did not have to do any of these computations over here. Since we did sorting, the runtime of sorting will be n log n. This is something you could review from any of algorithm that structures videos on YouTube, but sorting, that's the worst case runtime, n log n. And I believe that's the merge sort. So that will be the runtime. Okay, so I think we can start now. Let's do the coding part, and I'll see you next video.